All right, welcome back again. This is Chapter 1, Section 6, Solve Linear Inequalities. All right, first off, a linear inequality is just like a linear equation. So look back over your notes, look up what a linear equation is. Well, this time it has an inequality. All right, that means less than, greater, and then this would be it has an equal to. All right, so compound inequalities, they have two simple inequalities. So you basically have like, x plus 2 is greater than 4, but it's less than 10, something like that. Equivalent inequalities are inequalities with the same solution. Inequalities with the same solution. All right. All right, so here you go. Let's graph some of this stuff. This reads x is less than or equal to 4. So the solutions are all real numbers less than, less than, yeah, that's right, or equal to 4. A blank dot is used to graph to indicate 4 is a solution. A closed dot or a solid dot might be a better word for you to use. So a solid dot at 4 and all the numbers that are less than 4 goes that direction. Graph x is greater than negative 2. Those solutions are all real numbers greater than negative 2. And for this one, since there's no equal to, it is a open dot. Or I guess you could just say it's a circle at negative 2. And since we're greater than, we do all the numbers greater than it. Check this one out. X is less than or equal to negative 1. And we have a solid dot. So negative 1, solid dot, less than. Here, pause the video, try it yourself, see if you can do it. Should be something that you are used to in Algebra 1. And once you get it, you should see that you have a circle at negative 3 and everything greater than it. All right, these are compound inequalities. So, two simple inequalities. The solutions are all real numbers that are less than negative 3 and greater than 1. And what type of dots? Here, it's a circle and a circle. Solid dots. I'm sorry, open dots or circles. So negative 3, circle. 1, circle. We are less than negative 3, and we are, oh, whoops. Let me rephrase that. We are not less than. It's saying that the solutions that are less than negative 3, oh man, I messed that all up. All right. cross that out. This is what's nice for me is I can erase it. You're going to have to actually use the pencil or scribble it out. This right here, since let's look at this part. This is saying x is less than 1. And then it's saying since the bigger side of the inequality is on the x, then it means it's greater than the -3. So you still have an open circle at -3, but we're greater than that. So it's everything in that direction. We're less than -1, so we're everything in that direction. That means what they have in common is in between here. All right, you only do the in between. This way right here, you would say in between. This is an or statement, so it means it's either or. There's no commonality. There's nothing that it has in common. Let's see if I can do this right. So the solutions are all real numbers that are blank than. All right, so looking here, x is less than -1 or greater than or equal to 1. Right here, open dot. Over here, solid dot. Solid dot at 1, open dot at -1. And when you have an or statement, maybe you should add this. Or statements, you basically can follow the arrows if you want. This arrow is pointing to the left. The other arrow is pointing to the right. So pause the video, try this on your own, but I'm going to keep talking. I'm not going to do all the extra work, but I'm going to say that x is less than or equal to 0. That means this is a solid dot at 0. This means an open dot at 2. And the arrows point to the outside. Guided practice number 1 and 3. Let's just take a look at 3. 3 is -3 less than x less than 1. There you go. This is on page 41. There's your number line. There's 0, 1, 2, 3, -3, 3. Closed circle here. Open circle there. And this is an in between. The x is between -3 and 1. Alrighty. So this part is set up in your textbook as well. For this, add the same number to each side. What that means, basically for this, what you're talking about is whatever you do, all stuff you do to equations, you do to inequalities. There's one exception. If you multiply or divide by a negative number, you have to change the inequality. All right, so that means adding the same number to each side, same thing you can do with an equation. So add 7 to both sides. And you end up with x is less than 11. You can subtract the same number from each side, so -3. Then x is greater than or equal to -4. Here, you can multiply each side by the same positive number. The positive part is important. So you're going to multiply by 2, and x is greater than 20. You can divide by positives. Divide by 5, x is less than or equal to 3. Pause this or slow this down however you need to. if you multiply each side by the same negative number, you reverse the inequality. So this will multiply by -1. If you multiply or divide by a negative number, change the inequality. So instead of less than, it's greater than. Here, divide negative number. Divide by -9. Becomes 1. X is something -5. You have to change this into a less than or equal to. You just basically flip it around. All right, solve an inequality with variables on both sides. Treat it like an equation, but if you ever divide by a negative, you have to remember this part right here. So, write the original equation, subtract the smaller from each side, subtract 4x from both sides. I would subtract 4x from both sides. I would subtract the smaller of the equations, but for the purpose of setting this up, you're going to subtract 9x from both sides. So minus 9x is -5x. You're going to then subtract 5 from both sides. -5x is greater than -15. Divide each side now by -5. And switch or flip the inequality. So they're all real numbers. The solutions are all real numbers less than 3. So less than is a circle, and it's less than. If up here, if we had done it the way we've talked about in class before, then we wouldn't have to worry about the inequalities at all. You would have you'd have the right inequality. You would never have had to flip it. All right, here, let's solve this. And let's do it our way. Let's subtract x from both sides. Now you've got -2 less than or equal to 3x minus 8. Now we plus 8 on both sides, just like we would if this were an equation. That becomes 6 is less than or equal to 3x. Then we divide by 3, and we get that x2 is less than or equal to x. Now, what type of dot? You should all say a solid dot at 2. And now the question is is the x bigger than 2 or is the x less than? And you look at it, this part right here. The bigger part of the inequality is facing the x, so we should be in that direction. All right, this one here, there are no variables on both sides, so we just add 6 to both sides. -7x is greater than 5. Divide by -7. As soon as you say divide by negative, you need to flip the inequality. -5/7. That's about negative point, shoot, what is it? About -0.7. So 0.7, -0.7 gets a circle. It's everything less than that circle. All right. We shouldn't be much longer. I don't want these videos to be too long. Oh, yeah, just a few story problems to go. All right, guided practice 5 and 7. I'm just going to choose the hardest one. Let's look at number 7. You should be able to do the rest. 5x minus 7 is less than or equal to 6x. So let's move the smaller of the two. -7 is less than or equal to x. We're done. Make a number line. We'll make that 0, 1, 2, 3, 4, 5, negative. And what type of dot do we use? Hopefully you all said solid dot at negative 7. And since the inequality, the variable is bigger, is on the bigger side, that means we go in that direction. Alrighty. Here's another example. Let's solve an and. All right. It looks more complicated, but if you just think about it, what you do to one side, you do to all the sides. So write an inequality. Add 2 to each expression. So if you add 2, well, I guess it has space for us to do it in. If you add 2 to everything, to all sides of the expression, the minus 2 and plus 2 cancel out. This becomes negative 5. That becomes 10. Then you divide each expression by 5. So divide by 5. Divide everything by 5. The 5's cancel. It becomes 2 and negative 1. At no point do you switch the inequality, because you only divided by a positive. So the solutions of real numbers are less than negative 1. Oh wait, hold on. I got to slow down whenever I do this. I got to make sure I say it right. So x is bigger than negative 1, and it's less than or equal to 2. So open circle, solid dot, and it's an in between. So it's everything in between those points. All right, solve an OR compound inequality. It's the same setup. You're doing it twice, though. Look at the first one right there, and then do the second one. So 4x minus 7 less than 5, less than or equal to 5, write the inequality. Add 7 to both sides. 4x is 12. Divide by 4. You get 3. So the solutions are all real numbers less than or equal to 3. Or subtract 2 from both sides. Divide by 3. Or greater than or equal to 7. So, what kind of dots? Let's see here. Solid dot there. Solid dot there. Those are solid dots, and we're less than one of them and greater than the other. So that's an OR statement. All right, checkpoints. Checkpoints, and then we're done. All right, did a good job getting this one over with. All right, so here, it's a compound one. Subtract 5 from every side of the inequality. Divide everything by 4. And now we've got an in-between statement with an open dot at 2, an open dot at 4, and it's everything in between. Here's another that is an in-between statement. Add 3. Divide by 2. And now you've got a circle, a closed dot, and everything in between. Here's another compound one that's an OR statement, so it should be, if it's an OR statement, it should be to the outsides of the inequality. We do equation number 1. Add 6. Divide by 2. X is less than 2. Equation number 2 here, don't add 1, minus 1. 26 minus 1 is 25. Divide by 5, x is greater than or equal to, oops, not 25, but greater than or equal to 5. So, open circle at 2, closed circle at 5, and it should be x is less than, it should be away from each other. They don't like each other. All right, rewatch that video if you need to. Rewind it. Go over the all the guided practices, and then maybe even look over the practice problems, and then we'll work on them in class. Good luck.